Thank you all for joining our ETRAGE webinar. Today I am joined with one of our partners, FISNA. Since 2016, they have been helping companies utilizing CAD work smarter by utilizing their advanced AI tool we will be sharing with you today. Some quick housekeeping notes. Everyone is muted, so we ask that you use the Q&A icon for any questions that you have during today's presentation, and we'll answer those most likely towards the end, though we do encourage you to write those in as they come up throughout today's session. We will be recording today's webinar, and that will be available on our ETRAGE YouTube channel, and anyone registered today will also receive a link via email. Advance our slides. I am Sinead, and joining me today is Ralph. We both reside in the great state of Ohio and have been working for several decades in the world of design and manufacturing. I love working with Ralph because, like me, he is solutions focused. ETRAGE and FISNA work together to understand your business challenges, and if there are any ways to automate or eliminate risk, we will share that with you. So today's agenda, most of the time will be spent, Ralph will be showing you the technology. He'll go through a demonstration of this CAD agnostic platform that you can search, compare, and classify 3D CAD. He'll show you how the solution can benefit departments across your entire enterprise. But before that, I'll introduce you to both of our organizations. ETRAGE is a global company with over 20 years of experience helping PLM adoption extend beyond engineering and across your entire manufacturing enterprise. And we do this by addressing the needs of your systems, your management, and your end users. We understand that adoption is not a one-time event. It's a strategic, ongoing process, really focused on continuous improvement. And it's evolving as your business evolves. FISNA is one of those strategic considerations. Investing in systems to streamline, reuse, and redirect your resources and people to be innovative, to utilize design comparison, inventory management, and supply identification. ETRAGE and FISNA work together across industries, and so I'm very happy that they could join us today. ETRAGE, I said, our mission is to support PLM adoption, which also means that we support CAD modeling. FISNA is a CAD-centric business solution. So, like ETRAGE, FISNA is an enterprise solution. So let us start by asking if you've heard any of these questions in your company before. Are there parts that we can reuse for a new product? Where is that design that I built 3 years ago? Where have I bought similar parts before? What changes are in that revision? Do we have something similar in inventory? How can I price this? I'm betting you have, and you'll notice that these questions come across all departments across your manufacturing enterprise. The question that we have is, how do you answer them? How long does it take you to answer them? Potentially, do these questions go unanswered in your organization? Do they slow down your ability to get your product to market? So you can see that this is not just an engineering problem, this is a manufacturing problem. And while these types of questions come from different corners of your manufacturing, they're all CAD related and CAD management related. And so this is where ETRAGE and FISNA come together to partner. So we will say that there are other geometric comparison tools out on the market, though we would also say that they're not all equal. FISNA is a CAD agnostic solution, meaning that it doesn't matter if your company is using Creo, Inventor, SolidWorks, potentially all, FISNA can help you. It also works with multiple PLM systems. Ralph will demonstrate many of these features that you see listed on the screen today. And if you have any questions, again, as the demonstration goes on, use that Q&A icon, and as many as the questions we can get to, we will. One thing I do want to point out that I think differentiates us in the PTC space is that first line you see, automated loading the data from Windchill to local folders. As a PTC partner for over 20 years, ETRAGE is uniquely positioned to help companies who are currently using or planning to use Windchill. And this I do want to quickly explain. So ETRAGE Publisher automatically loads data from Windchill and local folders. So if you had CAD data living outside of your Windchill, we can take that and automatically publish that into FISNA for you. We will be doing a webinar, our next webinar in February. This is February 11th, called Extending Your PLM Data Distribution to Third-Party Data Systems. And we are trying to provide that in our chat. So if you are interested, you can click on that at any time, and that will take you to that registration so you can find out more. But the thing about this tool, which makes it a powerful partnership with FISNA, is that we're also able to export the metadata from Windchill into FISNA. So if you have parts that say, describe what kind of materials, whether it's steel or aluminum, FISNA would be able to share that and compare your parts on that metadata. So Ralph will probably most likely get into that, but just wanted to share how we're partnering to get the most out of the data you already have in your Windchill and be able to use that in FISNA. So with that, Ralph, I will hand it over to you so you can show everyone the magic that is FISNA and your CAD agnostic platform to search, compare, and classify 3D CAD.
Fantastic. Thank you, Sinead. I wanted to recognize also my colleague, Kevin Hoffman. We work closely together. And so Kevin, as questions come in, Sinead, you guys can monitor. I have only one screen. I'm traveling, so I won't be able to see everything as I share. Let's see over here. Let me share my screen and make sure everything is available. And then let's switch to this. Okay. So thank you, Sinead, again. It's data is king, right? That's the saying. It's without ETRAGE bringing in the data into FISNA, we can't do this kind of magic that I'm going to show you. So we're very, very proud and pleased to be partnering with ETRAGE here. FISNA is an interesting name, stands for Physical DNA. It's a company that is supported by Sequoia and Google Ventures as a startup. But we actually have been in the market doing our business for quite a few years. And it all started with this concept, the physical DNA, again, from where the name FISNA comes from. It's a patented algorithm that extracts, you can think of it as a string of vectors that describe perfectly the geometry of any 3D object or assembly, part or assembly, in such a way that if two physical DNAs are the same from two different parts, perhaps a CATIA part and a step part, if the algorithm points out that they're the same, that means the two parts are the same. So in this example here, this step file and this CATIA file, they're exactly the same because that's what FISNA is telling me. What gets fun is that sometimes parts like a left hand, right hand bracket, they're very similar, but they're not identical. So here you see already a little bit of a difference. It's not 100%, it's very close. Figuring out that you have a whole bunch of these in inventory and just a few usually points out a problem, because usually when left hand and right hand go together. So that would be a very simple example where it's useful to know that you have these mirrored pairs. And then here's an example of a piece of sheet metal that's bent just over here by a little bit. Its physical DNA is very similar to the physical DNA of this other one, and yet they're not the same, so there's a percentage number. And FISNA is a deterministic algorithm. It's using geometry, not AI, so it doesn't hallucinate. It repeats every time the same answer. We do use AI to enhance our query capabilities, but the core algorithm is actually pure math. So now here you have an example of an assembly where the physical DNA is a little bit longer because there's more geometry to describe. And here's an example of a subcomponent of that assembly. And it has its own physical DNA that is embedded in the physical DNA of the larger object. I like to show these slides to begin with, because when I demonstrate what FISNA can do, it looks a little bit like magic. And so it's really good to ground yourself, come back to, okay, it's just a bunch of strings of data that now I can search using precise searches, like in the case of finding this object in this assembly, or very similar strings that leads to very similar parts. We've literally codified the 3D world into a string of vectors that is a very powerful concept. And so the best way to understand it is to see it in action. So I'm actually going to switch over here to FISNA and show you what it looks like through its web UI. So FISNA runs on cloud platforms. It's containerized so that it can be deployed easily in all sorts of environments. We do, for example, do business with the US Air Force. And so we've gone through the whole part of having DoD impact level 5's capacity that meets FedRAMP high standards. So from the security perspective, I think we're well covered. But from the simple, how do I access? It's just a browser. You don't need a plugin. There are no special CAD licenses. And yet you're able to manipulate data, 3D data, using folders and subfolders, and then be able to literally point and click and be able to and see 3D objects and manipulate them in any way you need. So as every other search engine should have, we are able to search in 1D. So if you type something like a keyword that hits elements of metadata, so you see here, I'm looking for seats. I'm finding seats. This database, I'll talk a little bit later about where the data is coming from. So what I just did there is called a 1D search. I typed a word and it found it in the metadata. If I click over here on the little camera icon, if I'm using a mobile device, then it's going to use its camera. In this case here, I'm using a PC, so I'm going to load a file full of pictures, let's say a folder full of pictures, and I'm going to use this retaining ring. So I just gave FISNA an image of an object. I'm not too sure what it is. I can give it multiple images if you do have them. But look how quickly FISNA was able to look through its database and its 3D geometry and render all the objects that it has until it found the one that matches exactly the picture. So now I know this is an MSC 20414. And if I use that to search, FISNA comes back and tells me it's 100% sure that this assembly and this retaining ring here go together. So I'm going to ask it to compare. And I want an exact comparison of where they intersect. And let's change the opacity of the larger object. And there, in a matter of seconds, I went from picking up something on the ground, on the floor, figuring out what it is through a picture, and now I know where it came from. And this is a live system, so you're seeing the performance of the system as it really exists. So how can this be used? Well, take, for example, you're looking for a bolt. This is a classical case across all industries, and the bolt is not in stock. So all you have to do is search using FISNA, and FISNA will tell you, I found several possible matches. The top one is a 100% geometric match. And now I apply all the metadata to make sure that it is exactly what I need. So this one is made out of steel. It is in stock, and I seem to have it in, Granger has it, and $2.50. So there, in a matter of seconds, I went from, I have a problem with obsolescence, an object that I can't find in my inventory, to I just found your supplier with a 100% match. Now, this example here, a 96% match. Now, this is where it really gets interesting. You would never think of comparing the XX58949 bolt to the bolt named in French. And yet FISNA does do it because mathematically, geometrically, they're very similar. And I can put them side by side and let FISNA show me through its tools, what's the depth over here. Let's see, over here, I can measure this Phillips kind of symbol. And this gives me a good idea that they seem to be very much the same. I mean, the 96% already speaks lots. But look how more interestingly, I can ask FISNA, show me exactly where are these two bolts different. And FISNA highlights, it's really just at the top. So going back to the search, this object is a potential substitute for this one if that little plus symbol on the top is not relevant functionally. And that's the power of FISNA, the ability to find not just identical but similar parts and candidates for simplification. Let's say I have both of these in inventory. Perhaps I don't need to keep both of them. And the savings can be quite substantial. Now, when I queried using that bolt, FISNA also went ahead and searched for locations where the bolt fits. So it would be a part within a part kind of search. And here we have the turbocharger, 100% guaranteed to be to host the bolt. So let's take a look at that. Let's intersect the turbocharger with the bolt, and there we get a multi-match. So I need 8 bolts to service the turbocharger. The fact that I don't have the bolts means I've got an 8x problem. And it's as simple as I point and click. So you don't need to know a lot about CAD systems. You don't need to know a lot about geometry. The system is quite intuitive. And again, if you search using an assembly, not just a part, that's not an issue. Over here, I'm searching using the subcomponent of the turbocharger, and there it says the next level higher up is the turbocharger itself. And again, I'll show you the full workflow. If I put the two together and I compare them, then I want an exact comparison of where they intersect. I should see that intake valve and the turbocharger put together, and there it is. And again, if I want to see just the original part there, that really kind of helps me see where it fits in the world. If you're dealing with an electronic component like a capacitor, where all the properties are extremely important, you can also use FISNA because FISNA will match that capacitor across all its circuits, all the circuits that it has in its database. So in this case here, FISNA has matched that capacitor and found it over here. Or again, I can just ask FISNA, show me where. And turns out there are 2 capacitors. And if I'm dealing with this whole circuit over here, so it's kind of navigating in a 3-dimensional way, I'm really interested in seeing what else do I have in my inventory that can be used to assemble this circuit. Well, it's just a search. And then FISNA comes back and tells me all the other circuits that are very similar, but then all the subcomponents. Look how interesting. So like, let's say I'm looking for this chip over here. I can add the circuit and the chip together, compare the two, and then ask FISNA, show me exactly where do they intersect. And you can see it's the same workflow. That little chip, I would probably not see it if I were just looking from the outside, but FISNA sees the inside and the outside, and so there's the chip. That's where it's positioned inside the circuit. And FISNA is extremely capable in terms of visualization. So over here, I'm comparing two valves, and FISNA tells me that an 82% match. So that's kind of interesting. How could they be? They seem very similar. Well, let's put it in X-ray mode, and there you see it. One is a Tesla valve, the other one is not. Hence the difference. So I mentioned we kind of operate on CAD files, multiple different formats. The formats extend from Dassault, from PTC, from Siemens, open standards. So SolidWorks, Solid Edge, Autodesk, that's not a problem. We can literally see across all those formats because we use a standard physical DNA as the comparison tool. So where does all this data come from? Well, it comes from product lifecycle management solutions, and it also comes from the market. If you look at McMaster-Carr and you take any one of their objects, you will see it's available in several 3D formats, and it includes product detail. And they make it really easy. I'm not even logged in, and I can have access to all this information because it speeds up sales. That's why the vendors are making it possible and easy for you to access 3D data. And we do partner with these companies to be able to access their data and make it available to you as well. Here's another example, Trace Parts, with over 170 million objects from over 2,000 vendors in 3D. So when you're searching, you can search within your own library, or we can help you extend and search across different libraries as well. Now, if you say, well, I deal with very old equipment and sometimes I don't have access to CAD, well, if you can scan the object, give me a use LiDAR scanner or photogrammetry, then I can use that as a search criteria as well. And FISNA comes back here and shows me multiple matches and even CAD files that correspond to that scan. So what I'm showing you at scale means the following. If you take a complex system, like a submarine or an airplane, and you take a warehouse or a simulated digital twin of a warehouse of all the things that you purchase or plan to purchase, you can ask the question, what are the things in the warehouse that can be used to service the submarine? And the answer is just an intersection of the two. Geometry doesn't lie. So here you have all the elements that are in the warehouse and in the submarine, independent of labels. It can have as manufactured, as stocked, as purchased numbers. That doesn't matter. We're just looking at the geometry to match exactly what you need to see. So let me go back here to slides and show you just one more example of how FISNA can be used. We did this with NVIDIA a few months ago. They have this environment called the Omniverse, where they do a lot of 3D simulation. They have these objects. I picked one of them, labeled it as a man, and gave FISNA a command line interface command saying that if you find anything that's within an 80% threshold, go ahead and label it the same way. So this is what it did, and then recursively, this is what it produced. As you can see, using geometry, I can organize, classify my inventory very quickly, very efficiently. So let's take a step back. I showed you that I can search using text when I typed in the word seat, or image when I had the retaining ring. And when I perform these searches, I find 3D objects, data about those 3D objects, like for example, where it fits in the world. That's one type of search. I can use that to classify, organize, kind of assess my inventory levels. I've got advanced visualization, and yet the learning curve is not steep. CAD systems are notoriously hard to use, as hopefully you've seen through this demonstration. FISNA is not. I can see across different file formats, so that enables mergers and acquisitions analysis. Do they purchase the same things I purchase? I can perform analysis at scale, as I've tried to show you with the submarine and the warehouse example. And even if you don't have CAD, if you're dealing with old equipment, but you can scan it, that's a really good way to start. So these are the kind of the technology features. Now let's take a look at how do we apply this in the industry. So I'll take an example of before FISNA, actually, of something that the Air Force, or actually the Navy in this case, performed in the early 2000s. They looked at the Virginia class and the Seawolf class submarines, the bill of materials, and they went through each and every item. Whenever they found two parts that were the same but had different names, they standardized. Whenever they found two parts that were very similar, candidates for standardization, for simplification, they went ahead as well. In doing so, they spent $27 million, 544,000 man-hours, but the effect of eliminating duplicates and standardizing was $1 billion with a B. So this whole effort took over 4 years to accomplish. This effort now, we're about to start a very similar effort with the Navy. It's going to be done in weeks, because FISNA is going to do all the comparisons, finding all the matches, all the candidates for simplification, as opposed to having human beings combing through extensive sets of bill of materials. That's the power that we're putting in the hands of commercial businesses and the military, the DoD or Department of War nowadays. And it all starts off with the ability to pull data from different warehouses or different weapon systems or different anything that has a 3D element to it, which really kind of spells out why the partnership with ETRAGE is so important, because data is king. I'll leave you with this slide here of some ideas of what we can do with FISNA. Optimize inventory, enhance maintenance efficiency by connecting geometry of an object that breaks very often all the way back to design and preventing the introduction of duplicates or problematic parts into the supply chain. It really, if you're dealing with 3D, you should think FISNA, because we definitely have something here that I think is worth looking at. So that concludes my presentation. I'll be happy to address any questions.
Thanks, Ralph. Yeah, if you have any questions at this time, go ahead and use that question mark icon. I'm gonna share my screen again while we wait to see. We'll share some of our up and coming events. So as I said earlier, our next webinar in February is focused on our ETRAGE publisher, where you can take data, whether it's from a local network drive, Windchill, even Teamcenter, and be able to distribute that to FISNA, our viewing system, another network drive, shared point, a lot of options there. From there, we'll be focused on PTC Creo. We'll be looking at cabling, Creo tips and tricks. And then also, if you have anyone looking to take a Creo administration class, we will be offering that in March virtually, so anyone can take that class. It does look like we have a question. So Ralph, he answered yes. So I'm going to read it out loud so everyone can hear what the question is. Is FISNA able to search annotations that are part of MBD, model-based definition?
Yes. So this is something we were just doing together with ETRAGE very recently. It's the ability to extract metadata from the file itself. It's very common, and it's something that we can do. We want as much data as possible, right? So yes, this is very much part of a project. It's interesting to look at the market, how model-based systems engineering is being adopted at certain pace. But yes, model-based definitions are definitely something that we are interested in gathering, and we do know how to do that.
All right, any other questions? Well, if you have any questions that come up afterwards, please email me. I will make sure that Rolf gets those and that we get answers to you. As we wrap up today's webinar, I do invite you to visit our website, learn more about ETRAGE and our other solutions, both software and service related. We're happy to start a conversation about any of the challenges that you're having around your systems, your management, and your end users. A reminder that a link of today's session will be sent out via email before the end of the week so that you can rewatch or share with your colleagues. I want to thank Ralph and Fisna again for joining us today and sharing your technology with us. And I'd like to thank everyone for joining and attending. We will see you next time.